What is the inverse of f of x here? Well, before I even get going solving this, since there's no multiple choice on this review, I'm going to have to use the algebra to solve. But I want to remind you that if you're given a multiple choice question finding inverse, you can do so. You can find it with a calculator without knowing any math whatsoever, just knowing the concept that an inverse means you are switching x and y. That was an ugly T there. Switch x and y. If you switch your x and y and graph it, you'll get a picture in the calculator that will be the graph. What am I talking about? This is the y right now, so it's in y equals form. If we graph x equals 5 over x y minus 1, we'll know what the image of the inverse should look like. And if it's multiple choice, you can just match graphs. But let's not cheat like that. Let's go through and solve. So here we switch x and y just like we would in the calculator or in the graph. But to solve algebraically, you go ahead and solve for y now. So I'm going to continue on by saying, all right, how do I get rid of this denominator? Because that's the part we don't like, is you would multiply by it, because right now this denominator is dividing. So if I multiply both sides by y minus 1, these factors cancel out. And so I have 5 on the right side equals, and if you distribute here, you have xy minus x. Again, I got that by distributing. I multiplied y, and then I multiplied by -1. And so I have this. Now the trick is you keep your y's on one side, and you move everything that's not a y to the other side of the equal sign, which in this case means I'm only moving one thing. I'm going to move the -x over here. So I'm going to add an x, so I'd have xy. I'm adding because right now it's negative, equals x plus 5. It's a positive x. This is a positive 5. There's a negative x on the left, so on the right it becomes positive. Now the last step, to get y by itself, I'm going to divide by x. Now don't make the mistake of thinking you can cross out these x's. You can only cancel if they're factors. This is not a factor. Well, x plus 5 is a factor, but not x by itself because it's not multiplying times the 5, it's adding. This x I could cancel out because it was multiplying times the y. Factors multiply, terms add and subtract. So my equation, my inverse, if you will, is you would write f-1 equals x plus 5 over x, just like that. So now, if this is my inverse, what I said earlier is, let's pretend this is multiple choice test. You would have 4 different types of equations given to you, and this one would have been hidden in there somewhere. If we would have graphed this from the start, this graph should match this one. Let's check it out. So I go to my calculator, I'm going to add a graph, and I'm first going to do what you could have done from the very start and said, okay, I can go menu, actions, text, and type in what I know will give me the image of the inverse. All I do is I switch my x and y from here. I switch them, hit enter. Now nothing happens right away. That's because you have to drag this to an axis. Once I drag it, now that's the image of the inverse. This is what the image should look like. So now if I was on a multiple choice test, I could just graph my different equations that they give me and see which one turns out to be the correct answer. In this case, we're saying it should be x plus 5 over x. So I'll type in x plus 5 over x. Hit enter. Notice my graphs are a perfect match of one another, so we did in fact do it correctly. Now as I come back over here, I do want to remind you that the domain and range would obviously switch, because when you switch x and y, x stands for domain, x represents the domain, y represents the range. Now this right here is not a part of this problem, but I just want to point this out. If I looked at the original graph, let me type that in, we'll say it was y equals 5 over x minus 1. Okay, now if I check out this graph, we should notice something. Okay, we should notice something here. The blue is our inverse. The red here is the original. If you look at this original, you notice that there's an x value that cuts this graph. There's an x value, or a vertical asymptote at the line x equals 1. And how do I know it's exactly x equals 1? Not only does it split the graph, but if you look up here, 1 is the value that would make us be dividing by 0. So the original domain, I'm going to do this. I'm going to say the original domain, I'm going to label this way, and the inverse, I'm just going to do d -1 representing the inverse domain and the inverse range over here. And so this is looking at the red. The red refers to the original function. The domain would be that x cannot equal 1. The y value that it approaches is 0 on both sides. So we would say the range is that y cannot equal 0. Now, as we pay attention to the inverse here in blue, we notice that those asymptotes aren't in the same places. This asymptote would be here, and this asymptote would be here to split the blue. Notice that this is x equals 0, or x cannot equal 0 rather for the domain. That's the spot that splits it. And over here, it's that y cannot equal 1. Notice these have just flipped spots because we switched the x and y.